Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. Step 1. Naming positions A, D, part X. A is the starting point of the reaction coordinate. At relatively low energy, this represents the reactants. B is the first and highest energy peak on the curve. This is a transition state, specifically TS1, the first transition state. Transition states are energy maxima on a potential energy diagram. C is the energy minimum between the two peaks. This is a reaction intermediate. Intermediates are local minima, valleys, between two transition states, meaning they have finite lifetimes unlike transition states. D is the second, lower energy peak. This is another transition state, TS2. It is also an energy maximum, just lower than B. Step 2 part Y. Are both reaction pathways exothermic or endothermic? Both pathways, solid ending at F, dashed ending at E, have their product energies, F and E, lower than the reactant energy, A. Since the products are at lower energy than the reactants, both pathways release energy. Therefore, both are exothermic. Step 3, part Y. To which step is the rate determining step, RDS? The RDS is the step with the highest activation energy, the highest energy barrier from the preceding energy minimum. B is higher in energy than D. The activation energy from A to B is greater than the activation energy from C to D. Therefore, the step going through transition state B, the first step, is the RDS. Answer B. Step 4 part Y. 3. Which product is most stable? Stability of a product is inversely related to its potential energy. Lower energy means greater stability. From the diagram, F is at a lower energy level than E. Therefore, F is the most stable product. Answer F. Step 5 part Y. 4. Hammond's postulate for exothermic reactions. Hammond's postulate states that the transition state resembles the species, reactant or product, closest to it in energy. For an exothermic reaction, the products are at lower energy than the reactants, meaning the transition state is closer in energy to the reactants. Therefore, the transition state is reactant-like. Since the transition state is closer in energy to the reactants and occurs early along the reaction coordinate, this is called an early transition state. Option A. States early transition states that are reactant-like. This matches. Option B. Late transition states that are reactant-like. Late TS applies to endothermic steps, not exothermic. Option C. Early transition states that are product-like. Product-like TS applies to endothermic reactions. Option D. Late transition states that are product-like applies to endothermic reactions with high-energy products. Therefore, the correct answer for 4 is A. Therefore, the correct answer is X. A. Reactants, B. Transition state, C. Intermediate, D. Transition state, Y. I. Exothermic, 2B, 3F, 4A. Therefore, the correct matching is X matches A. Reactants, B. Transition state, C. Intermediate, D. Transition state, Y matches I. Exothermic, 2B, 3F, 4A.